All right, so we're trying to find relative minimum and relative maximum. We need to know the derivative in order to find the critical value. So we get 4x cubed minus 2x. And we want to know when that derivative is 0. So we can factor out a 2x from each of those terms, and we're left with 2x squared minus 1. So either 2x equals 0 or 2x squared minus 1 equals 0. So one critical value would be 0. The other one, actually there's a couple from this one, we get x squared equals 1/2. So if we take the square root of both sides, x equals the positive or negative square root of 1/2. Or you can write it as positive or negative root 2 over 2. So we end up with 3 critical values here. 0, negative root 2 over 2, and positive root 2 over 2. And in each of those, the derivative is equal to 0. We want to figure out what happens in between there. Well, negative root 2 over 2 is like about negative 0.7. So I'm going to use negative 1 over here, negative 1/2 in between, 1/2, and 1. So I'm going to put negative 1 into our derivative over here and figure out what kind of sign we get for our answer. So 2 times negative 1 is going to give us a negative number. If we put negative 1 in here, negative 1 squared is 1, times 2 is 2, minus 1 is positive 1. So we're going to have a positive. Negative times a positive gives us a negative for that interval. Put negative 1/2 in, 2 times negative 1/2, still going to give us a negative here. Here, 1/2 squared is 1/4, times 2 is 1/2, minus 1 is going to be negative 1/2, so this is going to end up being a negative. So negative times negative, positive. Positive 1/2 in there, this first part is going to be positive, second part is going to be negative again, so that's going to be negative. And then the last one, if we put 1 in, we're going to get a positive and a positive, which makes that a positive answer. So we want to know when the local mins and maxes occur. So let's look at each critical value. At negative root 2 over 2, the derivative is changing from negative to positive. So what do we get? Minimum. So at x equals negative root 2 over 2, we have a minimum. At 0, changes from a positive derivative to a negative derivative. That gives us a maximum. And at positive root 2 over 2, we're changing from negative to positive again, so that gives us another minimum.